So we're moving on to chapter 5 in Hibbler, and in chapter 5 it discusses the equilibrium of rigid bodies. So if we have a rigid body, it could be any shape, size, whatever, as long as it's rigid, and this rigid body has a system of forces that are applied to it. Call it force 1, force 2, force 3, and force 4. All right, and it also may have a system of couple moments. So it might have, let's say, it has 2 couple moments that are acting on it. All right. So we know from chapter 4 that we can take this system of forces and couple moments and we can reduce it down to a system to a single force, which we'll call our resultant force, and a single couple moment, which will be our resultant moment. All right, and we know we could locate it at any point in the body. We can do this. All right, we can find our resultant moment at that point and our resultant force at that point. So a rigid body is considered to be in equilibrium. So equilibrium for a rigid body occurs when the resultant force, or the sum of all of our forces, is equal to 0, and our resultant moment about a point, which is equal to the sum of all of our moments due to our forces plus the sum of any couple moments applied to the system is equal to 0. Right? So if MRO and our resultant force are equal to 0, then our particle is at equilibrium. And then the one thing that I would like to add is that if you tried to find the define the equilibrium equation at some other point on our rigid body, let's call that point A, and point A was separated from point O by a small amount. All right. Because the equilibrium was satisfied at point O, our resultant force we know is equal to 0, and our resultant moment is equal to 0. So if we found the resultant force about point A, it would be equal to our resultant force, so that would be equal to 0. And then if we summed all of our moments about point A, it would also be equal to 0, because our couple moment due to the force R would be equal to 0, because it would be equal to RAO cross FR, but we know that FR is 0, so that would be equal to 0. And then we had to add our couple moment, which was equal to the resultant moment at O, which we know is also equal to 0. So our equilibrium condition would be satisfied at point A as well. So in conclusion, if you find the equilibrium condition at one point in a rigid body, any point within the rigid body would also be considered to be in equilibrium.